Hello everybody and welcome to our video on the double and half angle formulas. So we're going to just start out by jumping straight into these double angle formulas. So these formulas are sine of 2x equals 2 times sine of x cosine of x. Tangent of 2x equals 2 times tangent of x over 1 minus tangent squared of x. And cosine of 2x equals cosine squared of x minus sine squared of x, or alternatively 1 minus 2 sine squared of x, or alternatively again, 2 cosine squared of x minus 1. So all of these formulas are actually very simple to get from the sum formulas. So if you know your sum formulas really well and you happen to forget one of these double angle formulas, you should be able to get them in just a few seconds. So proof of the first formula, sine of 2x. 2x is the same thing as x plus x. So if we apply our sum formula for sine, this is sine of x cosine of x plus cosine of x sine of x. But of course, since my angle x is the same here, and I can multiply in any order, these are really the same thing. So if I add one apple plus another apple, that's 2 apples. 2 sine of x cosine of x. So now we look at tangent of 2x, and that's tangent of x plus x. So we plug that into our sum formula for tangent, and we get tangent of x plus tangent of x divided by 1 minus tangent of x times tangent of x. And I've got tangent of x plus tangent of x is 2 tangent of x, and tangent of x times itself is tangent squared of x. So that gives us 2 tan x over 1 minus tan squared of x. All right, and the proof of 3, well, this is really 3 proofs in one. So we'll look at the first one first. Cosine of 2x equals cosine of x plus x. So plugging that into my sum formula, I get cosine of x times cosine of x minus sine of x times sine of x. That gives me cosine squared of x minus sine squared of x. So that's one of my forms of my equation. But there are 3 different forms that are useful. So each of these 3 forms comes in handy at various times. And I can tell you, these in particular, all of these double angle formulas get used a lot in Calculus 2. If you're going on to Calculus 2, you will see these formulas come up a lot in various problems that you need to solve. Okay, so here, how do we get our second formula, 1 minus 2 sine squared of x? Well, for that, all I do is replace cosine squared of x with 1 minus sine squared of x. Gives me 1 minus 2 of the sine squareds of x. Or alternatively, I can replace sine squared of x with 1 minus cosine squared of x. So I get cosine squared of x minus 1. Distribute that negative, that's another positive cosine squared of x. So we get 2 cosine squared of x minus 1. Okay, so we're going to go ahead and jump into evaluating some double angle formulas. So find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta, given that secant of theta equals negative root 3, and sine of theta is greater than 0. So the first thing I have to keep in mind is, in order to do this, I need to know all of the values for sine of x, or in this case theta, sine of theta, cosine of theta, and tangent of theta to apply my formulas. So I'm going to take my information about secant of theta and use that to draw my triangle and figure out the rest. So first of all, secant of theta is 1 over cosine of theta. So that means cosine of theta is negative 1 over root 3. So now when I look at this, I go cosine is negative and sine is positive. So that puts me in the second quadrant. And if this is cosine, I can think of this as x over r. So that would make my r the square root of 3 and my x negative 1. And so now I need to find my y. And so that's just the Pythagorean theorem. So we take negative 1 squared plus y squared equals the square root of 3 squared. That's 1 plus y squared equals 3. Subtract the 1. and I get 2 equals y squared. So y equals positive root 2. We take the positive root here because we're looking in the second quadrant. Okay, so now I have my full triangle, which means now I know cosine of theta. I also know sine of theta is root 2 over root 3. And I know that tangent of theta is negative root 2 over 1, right? This is divided by negative 1, but I can just rewrite this as negative root 2. And I'm not going to do any rationalizing now. You'll see that that actually gets handled in the problem when we apply our formulas, so it would be a little bit redundant. So sine of 2 theta is 2 sine of theta cosine of theta. That's our formula. Now, another recommendation I have when you're working on these types of problems is every time you need to use one of these formulas, you should write it back down in its original form. Because the more you do that, the better you'll have these memorized, the quicker you'll get them memorized, and the easier your problems will become. Okay, so this is 2 times, and sine of theta is going to be radical 2 over radical 3, times cosine of theta, which is negative 1 over root 3. So up top here, we get negative 2 root 2, and in the denominator, we get radical 3 times radical 3, which is just 3. So that's sine of 2 theta. As you can see, the square roots in the denominator canceled out, so we didn't end up having to rationalize anything. Now we take cosine of 2 theta, and you can use any of the 3 forms for cosine of 2 theta. That's fine, but I'm just going to use the first one. Cosine squared of theta minus sine squared of theta. So cosine squared gives me negative 1 over the square root of 3 squared minus sine squared, which is root 2 over root 3 squared. Negative 1 squared is 1 over root 3 squared is 3 minus square these square roots, I get 2 over 3. 1/3 minus 2/3 is negative 1/3. Okay, now we can move on to tangent of 2 theta. And tangent of 2 theta was 2 tangent of theta over 1 minus tangent squared of theta. Again, all we're doing here is replacing x in our formula with theta. So this becomes 2 times negative root 2 divided by 1 minus negative root 2 squared. That's negative 2 root 2 over 1 minus, and when I square this, I just get a positive 2. So 1 minus a 2. That becomes negative 2 root 2 over negative 1. The negatives cancel, and that's 2 root 2. So again, the main thing here really is taking the information that we're given to draw our triangle, and that lets us find the other values we need, the other trig function values. This part on the left that we just did, this is just plugging into a formula, right? Plug and chug stuff. As long as you have those formulas memorized, this part shouldn't be too much trouble. All right, so now let's move along to another set of formulas. These are the power reducing formulas. And this is another set of formulas that comes up a lot in Calculus 2 in particular. You often need these power reducing formulas to manipulate certain problems you're trying to solve. So they really do come in very handy in that particular course. So our power reducing formulas are as follows. Sine squared of x equals 1 minus cosine of 2x all over 2. Cosine squared of x equals 1 plus cosine of 2x all over 2. And tangent squared of x equals 1 minus cosine of 2x divided by 1 plus cosine of 2x. And this tangent squared one should make sense because it's just sine squared divided by cosine squared. So it simplifies very quickly to that, right? Which we'll see momentarily. But let's look at the proofs for these first two. So we get both of our power reducing formulas for sine and cosine from our double angle formulas for cosine. So cosine of 2x equals 1 minus 2 sine squared of x. If we subtract the 1 across, we get cosine of 2x minus 1 equals negative 2 sine squared of x. If we multiply a negative 1 to both sides, we get 1 minus cosine of 2x equals 2 sine squared of x. And then divide by 2, and that gives us sine squared of x equals 1 minus cosine of 2x all over 2. Now for our second power reducing formula, cosine squared of x, all we do is use a different version of the double angle formula. Cosine of 2x equals 2 cosine squared of x minus 1. I add the 1 to both sides, divide by 2, and I get cosine squared of x equals cosine of 2x plus 1 over 2. And again, for the tangent squared of x power reducing formula, you just write out sine squared of x divided by cosine squared, write those formulas there. The 1/2s cancel, and you get 1 minus cosine of 2x over 1 plus cosine of 2x. So now we're going to go ahead and use these power reduction formulas to verify that 1 plus cosine of 2x plus 2 sine squared of x equals 2. So this would be just like any verification problem from our trig identities section. We rewrite the left-hand side as 1 plus cosine of 2x plus 2 times, and then we're going to rewrite sine squared of x as 1 minus cosine of 2x over 2. The 2 over 2 cancels, and this becomes 1 plus cosine of 2x plus 1 minus cosine of 2x. And the cosine of 2x and negative cosine of 2x cancel, and we're left with 2. Done. All right, so now let's take a look at half-angle formulas. Now, these half-angle formulas are pretty simple to derive. They come also from the power reduction formulas. Notice that all of these formulas we've dealt with in the past two sections, right? We start with the sum formulas. That gives us the double angle formulas. We manipulate the double angle formulas for cosine, and that gives us the power reducing formulas. And now we're going to manipulate the power reducing formulas, and that's going to give us these half-angle formulas. So each one of these sets of formulas follows right from the set before it. All right, so all three of these formulas are very similar to the last ones. We have sine of theta over 2 equals plus or minus the square root of 1 minus cosine of theta over 2. Cosine of theta over 2 equals plus or minus the square root of 1 plus cosine of theta over 2. And tangent of theta over 2 equals plus or minus the square root of 1 minus cosine of theta divided by 1 plus cosine of theta. So, well, how do we prove this? Well, we'll just look at the proof of 1 and notice that the proofs for 2 and 3 are basically the same thing for their respective power reducing formula. So I start with my power reducing formula, sine squared of x equals 1 minus cosine of 2x over 2. And then I'm just going to do a little substitution and replace x with theta over 2. That gives me sine squared of theta over 2 equals 1 minus cosine of theta over 2. Right, if I plug that x in here, 2 times theta over 2 is just theta. Now I take the square root, and that gives me sine of theta over 2 equals plus or minus the square root of 1 minus cosine of theta over 2. Now that plus or minus comes from the fact that we're taking the square root of a square variable here. So there's two possible answers to that equation. So when we go to actually use the half-angle formulas, you have to determine from the context of the question whether or not you're using the positive or the negative root. So that's just going to be part of solving the problems. It's going to be figuring out which version to use, the plus or minus. Okay, so for this next example, we'll use the half-angle formulas to evaluate sine of pi over 8. So we've got a big hint here. It's telling us to use the half-angle formulas. So how can we write pi over 8 as theta over 2? Well, if I multiply the 2 across, I get 2 pi over 8 equals theta. So theta is really pi over 4. So in other words, I can say that sine of pi over 8 equals sine of pi over 4 divided by 2. So that means pi over 4 is my angle theta for my formula, and my formula is plus or minus the square root of 1 minus cosine of that angle, theta, pi over 4, divided by 2. Now we just have to figure out, is it plus or minus? Well, you just look at your original angle, and that's very important. Don't look at theta. Theta doesn't matter, and sometimes it'll be misleading. Look at the actual angle you're evaluating at. We're trying to evaluate sine of pi over 8. That's the first quadrant, so I'm going to use the positive root. So this becomes the square root of 1 minus the square root of 2 over 2, all divided by 2. And now we just do a little bit of algebra. I find a common denominator in the fraction up top. So instead of writing 1, I'm going to write this as 2 over 2 minus root 2 over 2, all divided by 2. And this becomes the square root of 2 minus root 2 over 2, all divided by 2. And now I can rewrite this as the square root of 2 minus root 2 over 2 times the reciprocal. Our denominator here is 2, so the reciprocal is 1/2. So I'm multiplying by 1/2. That gives me the square root of 2 minus root 2 over 4. And finally, I can split up the square root into the square root of 2 minus root 2 divided by the square root of 4. And the square root of 4 is just 2. So this is our final answer. Radical 2 minus root 2 all over 2. Okay, so the algebra can get a little bit tricky in some of these half-angle formulas. Got to just be really careful with what you're writing and take it step by step. The smaller steps you break it down to, the less likely you are to make mistakes along the way. Okay, so let's go ahead and tackle using half-angle formulas to evaluate tangent of pi over 8. Well, we already saw, based on the previous problem, that we can write tangent of pi over 8 as tangent of pi over 4 over 2. Where pi over 4 is going to be my angle theta in my formula. So this is plus or minus the square root of 1 minus cosine of theta divided by 1 plus cosine of theta. And again, we look at the angle inside the function, the original angle, to determine if it's positive or negative. Pi over 8 is in the first quadrant, so this is positive. This will give me 1 minus root 2 over 2 divided by 1 plus root 2 over 2. And I'm going to do the same kind of algebra that I did before, but I'll skip some of the smaller steps. So instead of 1 minus root 2 over 2, this will be 2 over 2 minus root 2 over 2. So I get 2 minus root 2 over 2 divided by. And then in the denominator, I'll have 2 over 2 plus root 2 over 2, which is 2 plus root 2 all over 2. And now I'll rewrite this division as multiplication by the reciprocal of this denominator. The 2 over 2's cancel. And we get 2 minus root 2 over 2 plus root 2. Now, this is a pretty tricky one to rationalize, and generally you're going to be expected to rationalize. Now, this is actually an exact answer. I would personally be fine with this, but when you're doing any sort of homework in a computer system, it's going to expect you to rationalize these answers. So, with that being said, how do we rationalize this? Well, if we're going to rationalize the whole thing, we first need to rationalize what's inside the square root. So we can do that by multiplying the top and bottom by our conjugate of the denominator specifically. So our denominator, we're going to get 2 times 2 is 4. The inner and outer terms will cancel, and then I get the square root of 2 times negative root 2. That's going to be negative 2. And up top, when I multiply this out, you got to be really careful with these problems because sometimes something really nice happens, and if you don't notice it, you'll multiply some stuff out that'll actually cause you problems. I'm multiplying 2 minus root 2 by itself here. So this is actually 2 minus root 2 squared. And since I'm taking a square root of this function, that makes my whole life a lot easier because now I can just say, oh, the square root of the top is just 2 minus root 2, and the denominator, 4 minus 2 is 2, so the square root of the denominator is just square root of 2. If I had multiplied all this stuff out, I never would have seen that this is just this number squared, and then that would have caused me a lot more difficulty. It actually becomes pretty much unsolvable at that point. Okay, so now that I've gotten rid of this outer square root, now I can just do another bout of normal rationalization. So I multiply the top and bottom by square root of 2 over 2, or the square root of 2 and the square root of 2 on both, I mean. That leaves us with 2 in the denominator, and when I distribute, I get 2 root 2 minus 2. That means I can simplify it one step further. I can factor my numerator, and the 2 over 2 cancels, and finally I get left with radical 2 minus 1 as my final answer. So again, with these half-angle formula problems, the algebra can be a little trickier. So take your time with the algebra, be really careful with your steps, think things through carefully and slowly, don't rush them, and you'll be a lot less likely to make mistakes. Okay, so now for this example, we're given that cosine of theta equals negative 12 over 13, and that theta is between pi and 3 pi over 2. So we need to find sine of theta over 2, cosine of theta over 2, and tangent of theta over 2. So the key thing here is to recognize that we don't have to do, we want to make sure we don't overdo the work. In this case, cosine of theta is given, and all of our half-angle formulas use cosine of theta only. Right? That's the only trig function that pops up. So I don't have to solve for any of the other trig values. So that makes this problem a little easier than it could be. But I do have to figure out what quadrant I'm in. So let's start by writing out our half-angle formula for sine plus or minus the square root of 1 minus cosine of theta over 2. So here's the thing. I'm told where theta is. Theta is between pi and 3 pi over 2. But I don't need to know where theta is. I need to know where theta over 2 is. That's actually very simple. Just take your inequality for theta and divide the whole thing by 2. Just go divide by 2, divide by 2, divide by 2. What does that give us? It gives us that theta over 2 is between pi over 2 and 3 pi over 4. Well, that's the second quadrant. If you're not totally sure, you can always sketch it out and say, Okay, well 3 pi over 4, that's there. Pi over 2 is here. So we're looking at the angles between these. Well, that's certainly in quadrant 2. So now that we know that it's in quadrant 2, that tells us that sine of theta over 2 is going to be positive here. So this gives us the positive root 1 minus negative 12 over 13 over 2. That gives us 1 plus 12 thirteenths over 2. 1 is 13 divided by 13. This gives us 25 over 13 divided by 2. But dividing by 2 is the same thing as multiplying by 1/2. So this becomes the square root of 25 over the square root of 26. The square root of 25 is 5, so this is 5 over root 26. And then we can rationalize and multiply by root 26 over root 26. That's 5 root 26 over 26. Okay, so now we'll tackle cosine of theta over 2. And again, it's plus or minus the square root of 1 plus cosine of theta, all over 2. The question is, which one is it? Well, we're in quadrant 2. So theta over 2 is in quadrant 2. So cosine is negative in quadrant 2. So that gives us negative the radical 1 plus negative 12 over 13 over 2. It's negative the radical of 13 over 13 minus 12 over 13 all over 2. That's negative root 1 over 13 divided by 2. That's negative the square root of 1 over 26, right? Because dividing by 2 is multiplying by 1/2. So this becomes negative 1 over root 26. And finally, we can rationalize. And we get negative root 26 over 26. Okay, now, with tangent of theta over 2, I could apply this formula. Plus or minus the square root of 1 minus cosine of theta divided by 1 plus cosine of theta. And the algebra basically works out the same way it does for any of these other problems. But if in the course of a problem, you already have to compute sine of theta over 2 and cosine of theta over 2, there's no reason to redo all this rather difficult algebra work, frankly. Tangent of theta over 2 is sine of theta over 2 divided by cosine of theta over 2. So if you've already done the work for sine and cosine, save yourself the extra time and just use those results. 5 root 26 over 26 divided by negative root 26 over 26. So I'll change this division into multiplication by the reciprocal. 26's cancel. That gives me a negative 1 here. The square root of 26 cancels. I get left with negative 1 times 5. That's negative 5. Done. So that's a lot easier, I think, than having to go back through the whole nother one of these half-angle formulas. So generally speaking, just keep an eye out for that. Any problem where you're already computing sine and cosine for those angles, you can just use your quotient identity for tangent, make things a little bit easier. All right, well, that's it for this one. Thank you for watching.